Example 5. So we're finding the maximum rectangular area that can be enclosed by 452 meters of fence. So we've got a rectangular area. It's got 2 lengths and 2 widths. We know that the perimeter of this thing, so both lengths and both widths, are going to be 452 meters of fencing. We know the area for a rectangle is length times width. What we need is we need to maximize the area. Again, we've got this maximum word, so we're going to be talking about the vertex. But let's figure out how we get a quadratic out of this whole thing. I'm going to divide this whole thing by 2, so I'm going to leave, so let's get rid of this for right now. If 2 lengths and 2 widths equals 452, a length and a width equals 226. Okay, I'm going to rearrange I'm going to rearrange this and solve for one of the variables. So let's just say that L equals 226 minus W. Back to this whole thing with the area being a length and a width. I'm now going to substitute in this length here. So my area is actually W times 226 minus W. And if I multiply that out, it is actually quadratic. So 226W minus W squared. All right, what we're trying to do is maximize this thing. So let me rearrange it into standard form. And if we were to graph this, which we don't need to, but I like to anyway, W is the input, which is our width. A is output, so that's our maximum area, right? It opens down, so it's going to look something like this. If we have a 0 width, we have 0 area. That makes sense, right? So what we need to find is the maximum. So we got to find this perfect width that's going to maximize our area. Let's grab the vertex. So H equals negative B over 2A. So our H is at 113. So the perfect width for this thing is 113 meters. And now we just need to find the area. So we said earlier that area is equal to, you can pick any of these formulas. We can use this one, we can use the multiplied out, we can use the multiplied out rearranged into standard form. It doesn't matter. We just need to plug in 113 for W. And then it's 226 minus 113. So it ends up being 113 squared, which is 12,769 meters squared. All right, find the maximum rectangular area. The maximum rectangular area is going to be 12,769 meters squared.